Welcome back. Today we're going to talk about the initial equations. If you've not subscribed to my YouTube channel, ensure you do so that we can make this to look real. So now, in my previous video, we've talked about laws of indices and other things. If you've not seen my previous videos, so I suggest or I advise you to go to my previous videos so you can be able to follow up whatever thing we're going to do from now. So now we have initial equation. First of all, an initial equation is any equation in which the power or exponent or index, power, exponent, index, the same thing. The exponent or index of the base is a variable or letter or alphabet. Occasionally, the base can equally be a variable, not just the power. As you can see here, this is the base and this is the power. The power is a variable. Here, the base is a variable. So in either case, it is called an initial equation. Then these are the rules, basic rules of solving initial equation. The first thing you do is to convert both sides to the same single base. To convert both sides to the same single base. So what do I mean by this? Then watch out here. If I have 4 raised to the power x equal to 16. Let me just use the example I have here. So I will have to convert this both sides to the same base in the sense that 4 raised to the power x equal to, I will ask myself 4 raised to the power what will give me 16 such that the base will be the same, which must be 4 raised to the power 2. Then 4 raised to the power 2, the base are the same. Then now watch. The second law says drop or cancel the base from both sides. You can now connect to why we say that we have to make both sides to be in the same base too. Make sure that number 2 will come into place. Then when number 2 comes into place, now we say that we should cancel the base. Because the base are not the same, we can now cancel the base. This is to tell us that if the base are not the same, there is no how we can cancel the base. Then when we cancel the base, we are going to take the powers to be equal to each other. It's called to equate the powers. Make the powers equal to each other. You find out that the answer is x equal to 2. Then this one says we should solve the resulting equation. Solve the resulting equation after you must have cancelled the base. For instance, if we have 4 raised to the power 2x plus 5 equal to 16. In this case, when you have 4 raised to the power 2 equal 4 raised to the power 2x plus 5 equal to 4 raised to the power 2, such that the base are the same. When you drop or cancel the base from both sides, you find out that the answer is not yet out. Rather, it gave you an equation which you had to solve. So, having cancelled the base from both sides, the next is solve the resulting equation. In this case, there is a resulting equation, which, if you want to solve further, we have 2x is equal to 2 plus 5 crossing to that side is minus 5, and 2x is equal to minus 3. Then to make x the subject, the simple thing you do here is to detach or remove these two and bring it under here. But in actual sense, we say divide both sides is by 2. Of course, when you do such a thing, 2 cancel 2x will be equal to minus 3 over 2. But in my previous videos, I will not be doing this. You just have to remove the 2 and bring it down here, and x will automatically be alone. And someone can say that this is equal to minus 1 over 2, and that eventually becomes the last answer. Then here is a very special case. If the equation can't be subjected to the same base, when they give you an equation, you find that converting both sides to the same base becomes impossible. A logarithm of both sides is taken to the same base. What does it entail? Watch this. I can have 0.5 raised to the power x is equal to 0.2 raised to the power x plus 3. In such case, no matter how you try, it is practically impossible to convert both sides to be the same base. So this means 5 over 10 all raised to the power x. That's when you change this 0.5 to fraction. It's 5 over 10 y's, or some you can say it's 1 over 2. But and this is equal to 0.2 means 2 over 10 as well. 2 over 10 all raised to the power 0 x plus 3. You find that even if you wish to divide further, this will give you 1 over 2 raised to the power x, and this will give you 1 over 5 raised to the power x plus 2. Can you see? This is the base and this is the base. These bases can't be converted to be the same. You find out that the only way to bear the cat is to do what? The only way to bear the cat is to what? Take a log reading, or a log reading of both sides is taken to the same base. So what's that supposed to mean? We have 0.5 all raised to the power x is equal to 0.2 raised to the power x plus 3. Only way out is the log reading of 0.5 raised to the power x equal to the log reading of 0.2 power of x plus 3. I'm not going to solve further, but in this log reading I already assume that the base is 10, so there is no need of me attaching the base here. So we're going to look into examples that will explain everything we've developed so far. So I'm going to end this video now, and the next one I'm going to talk about examples, miscellaneous cases involving indicial equation. Thank you and stay tuned.